Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope you all are doing really great. So students, in this video we are going to learn about magnetic dipole moment and we will solve questions also. Okay, so let's start the video. The topic is magnetic dipole moment. So kindly see here, a magnetic dipole consists of a pair of magnetic poles of equal and opposite strength separated by a small distance. Okay, so even if I talk about here one permanent magnet like a bar magnet, here you can see this is the north pole and this is the south pole. So here also how many poles are there? You can see two poles are there. Later you will see that here this north pole will be called here the plus small m, that is called pole strength, and this south pole is called minus small m, where m is also pole strength here. Okay, and later you will see in a next chapter the dipole moment direction always from south pole to north pole. In case of permanent magnet, that means magnetic moment is coming from the material. Okay, even if we talk about here the magnetic dipole moment of a magnet, and here what is there? The material is not there. What is there? The current is flowing. So in this situation, this kind of magnet is called electromagnet. So here also what is happening? Let's take the current is flowing here. The current is flowing here. Okay. So what will happen that here in this situation, when you will see this coil and the current is flowing in a which direction? Anti-clockwise direction, like this. Is it? You are seeing as your observer. So this side it will be the north pole here. Now you will see from here this side anti-clockwise direction, so north pole, and opposite side will be south pole here. Okay, and these two are different cases. This is the permanent magnet coming from this property is coming from the material, and here this property is coming from water, the flow of the current, and that's why the name is what? Electromagnet. Even you can see the example also. See here, magnetic needle, bar magnet, current carrying solenoid, and the current carrying coil or loop, etc. Is it? So after that, purely in this video we are going to talk about magnetic dipole moment that is coming from the electromagnet, that means current is flowing. Okay, this thing we will see in next chapter, magnetism and matter. Okay, so see, the topic is magnetic moment of current carrying coil, or we can tell loop also. So see, current carrying coil behave like magnetic dipole. As I have told you, one side north pole, when we are seeing the current is flowing anti-clockwise direction. So this side is what? South pole. Okay. And how to get the magnetic dipole moment of this kind of electromagnet? See, for a coil of n turns, each of cross-sectional area A, here area will be vector. We will see further why. Carrying current I, magnetic moment M is given by. Okay. So in this situation, the magnetic moment is given by, I will write here, this capital M is given by NIA. Very easy. What is this? NIA. If I write here in a vector form, so I have to put here vector sign and here also vector sign. Okay. And magnetic moment is the which kind of quantity? Vector quantity here, and its direction is along the direction of the area. Even in when we have calculated the electric flux, magnetic flux, there also we have taken area as a which vector? Means area we have taken as a water vector, is it? And that area vector direction is always perpendicular to the plane of the coil. Na? We'll see now. Okay, so see here, this one we have written due to the water electromagnet here. In this situation, later we will see in the next chapter, the formula will be capital M equal to small m into L. But this will come in a further chapters, where M will be the pole strength and L will be the effective length of the magnet. Okay, remember that. Next one, let's see, where vector A is area vector perpendicular to the plane of coil along its axis. Okay, A is what? Anyhow, area vector. Now let's see some important points here. So see, first one, magnetic moment is an axial vector. Why? We will see in this point. Okay, and if I talk about here the SI unit, what is the SI unit? You know very well. Number of turns, not having any unit. I means current, means ampere, and area means what? Meter square. Okay, so I can write here SI unit will be what? Ampere meter square, or sometimes SI unit we can write here joule per Tesla also. What is the SI unit? Joule per Tesla also. When we will learn the formula like a work done to rotate the magnet, W equal to MB cos theta 1 minus cos theta 2. From there we used to get this SI unit, joule per Tesla. Okay, see, dimensional formula. The dimensional formula is given by C. This is the current, so A meter square means L square. So AL square is what? Dimensional formula. Okay. Now the third point is very, very important. See, this further point, fourth point, see. Direction of M is find out by right hand thumb rule. What is this? See, according to this rule, if fingers of right hand is curled along the direction of current, okay, then thumb indicates the direction of a magnetic moment M, and from here itself we can tell this is the axial vector. Kindly see the example. Let's take here, for example, there is the one coil, okay, and this coil in a which plane? Let's take this coil in a ZX plane here. Let's take, for example, this coil in a ZX plane, okay, and what is happening? Let's take current is flowing like this here, okay, the current is flowing like this. Now, so what we have to do, curl your fingers of right hand along the direction of the current, then thumb will indicate the direction of the magnetic moment, okay. So this will be the direction of the magnetic moment, even this will be the direction of the area vector also, is it? If in case the current is flowing in a reverse direction, no? Instead of like this, current is flowing in reverse direction, in that situation what will happen that here, if I take here one more example, let's take here again, and in this situation let's take the current is flowing in a which direction? Reverse direction, like this, is it? And this coil in a which plane? Anyhow in a ZX plane here, see, this is X and this is Z here, okay, and what will be this? This will be the y-axis here. So in this situation, tell me magnetic moment in a which direction? Now again like this you have to curl your fingers, and in this situation magnetic moment in which direction? Downward direction. So when the direction of the current will change, the magnetic moment direction will change, is it? Very, very important. Can you see here? Okay, so we have got all these things. After that we are going to see very important topic. The topic is what? See, magnetic moment of a revolving electron. In a short form, this used to be called atomic magnetization. Okay, see what is this? See, let an electron Q equal to minus C, because electron is having how much charge? Negative charge, is revolving around a nucleus in a circular orbit of radius r with uniform speed v. Magnetic moment capital M of the electron is given by, okay. So what I am going to take here, let's take here one electron is there that is going to revolve around the nucleus. Nucleus is anyhow positive because it is having protons are there, okay, Z is there, and this electron is going to revolve, and let's take the radius of the orbit is how much here? R here, okay. So in this situation, if I talk about here the current, so what will be the current? The current will be Q. As of now, I am taking the charge Q because sometimes they will not give the electron, they will give some specific charge. So instead of minus C, I am writing here the Q. Now charge Q is there, so Q by T. And what is the T? T means time. Time means what? 2 pi r by v. That means time equal to distance by speed. So if in case at any instant the speed of the electron is how much here? V. No? Electron is revolving like this. So in this situation, what is T? T we can write here 2 pi r by v, okay, 2 pi r by v. Most of the time we will write here small r, not a capital R. What will be there, students? This will be the small r here, okay. So 2 pi r by v. So what will become here? It will become here qv by 2 pi r. This is the current. Even this is called orbital current, okay. After that, what will happen that here? If I talk about here the magnetic moment, what is the magnetic moment formula? NIA. Anyhow, the number of turns and all is not there, only one orbit is there. So N value is 1. And I, what is the current? Let's take here I into A. Okay. So what is the current? We can write here C QV by 2 pi r here, is it? And what is the area? Area, no, circle is there. So area will be what here? Pi r square. So from here, when you will write, what this will come? The formula will come here, very, very important. QVR, because pi cancel, 1R cancel. So this will come QVR by 2. What is coming? This magnetic moment is coming here. This magnetic moment is coming here. How much here? Remember that QVR by 2. Okay. And even for the circular path, we can use this formula also. V equal to R omega, that will be used in some of the questions, where omega will be the water angular velocity. But remember this one here, QVR by 2. This is what? Magnetic moment of the electron. Okay. This Q, later you can put the value E, also not a problem. It will become EVR by 2. Is it correct? Now let's see relation between M and L. What is M? Magnetic moment. What is L? This L is called angular momentum. What is L? This L is called angular momentum. Okay. So let me write here. You know very well what is the M. M formula we have got here, QVR by 2. Okay. And in a circular path, what happens that here in a circular path, angular momentum we can write here L equal to MVR. For circular path only, L equal to what? MVR. Now after that, if I divide both of them, okay, important, M by L. So if I divide both of them, what this will become here, see, QVR by 2, and L is what here, we can write here MVR. Okay, so we can cancel, whatever the things can be cancelled. Let's see here, this V and V cancel, this R and R cancel. Okay, so from here what we are getting that here, see, M by L is called here Q by, now this Q is left and here 2M. Q by 2M, is it? So this is the very important formula put into the box here. M by L equal to what? Q by 2M here. And if I talk in terms of the vector and all, so we can write here, see, vector M is equal to, for electron let's take, so electron means what is coming here, minus E by 2M into L. Okay, this is for the electron actually. When we are writing in a vector form, that Q we have to write here the minus E. Normally whenever we are dealing with the scalars and all that, just you write Q equal to E, not a problem. Okay, magnitude and all. So remember that here, very important. Okay, now let's see here students, this is the one table is there, you should remember that here, magnetic moment of few charged bodies. So this side name of the bodies, this side moment of inertia of the bodies, and this side is the magnetic moment. Okay, so see here, for the ring, moment of inertia will be what here, M is the mass, okay, and R is the radius, so mr square, when axis is passing through the center of mass and perpendicular to the plane of the ring. So in this situation you can see very well, Q by 2M, value of I how much here, mr square, so small m will what, cancel out, so we'll get the magnetic moment how much here, Q omega R square by 2. Q is the charge on the ring, uniformly distributed. Okay, next one, if we talk about here the disk, similarly, this moment of inertia formula mr square by 2, again you put at this point I, you will get the formula here, Q omega R square by 4, remember that. Hollow sphere means moment of inertia formula 2 by 3 mr square we used to remember, and again you put the value here, you will get here Q omega R square by 3. For a solid sphere, what is the moment of inertia? 2 by 5 mr square. M is the mass, capital M is the magnetic moment, don't get confused. Okay, then what this will come here, Q omega R square by 5. At least these 4 bodies magnetic moment should be remembered here. Okay, important. Now let's see, after that one more important topic is there, the Bohr magneton. What is Bohr magneton? Let's see. Magnetic moment of an electron in the first orbit, that means n equal to 1, of atom is called a Bohr magneton. Very simple, magnetic moment in the first orbit of the electron, first orbit of the atom, no? Because electron is revolving around the nucleus in atom, first orbit, okay, or we can tell K shell. So what is the mathematically, again I will write here, you know very well here, I have taught you M by L equal to what, Q by 2M, magnitude wise means I can write here E by 2M, is it? Now if I write here M equal to, this will become here E by 2M. Okay, E by 2M into L. And in a Bohr model second postulate, it tells that the angular momentum of the electron in any orbit is the integral multiple of h by 2 pi. L is what? N into h by 2 pi. This is the Bohr second postulate. Okay, this I will put here. So what this will become here, see, E by 2M, L value what is there? N h by 2 pi here. Okay. So after that, what is the value of the n in a first orbit? That means here I am going to put here the value of n1. So in this situation, what this will become that here, this m value will come here. Now just put here EH by, because n value is 1, by 4 pi m. Okay, EH by what? 4 pi m. M is the mass of the electron. So this value is used to be, remember that here, 9.274 into 10 to the power minus 24 here, unit ampere meter square. This is called what? This magnetic moment in the first orbit is called what? Bohr magneton. Remember that here, even the value or the formula also, EH by 4 pi m. Okay, great. Next one, let's see, one basic question is there. The question is, an electron in a circular orbit of radius 0.05 nanometer performs 10 to the power 16 revolution per second, the magnetic moment due to this rotation of electron is how much here? Okay, so magnetic moment we have to calculate. We'll note down the data. What is the radius? So we can write the radius is what is given, 0.05 nanometer. That means 0.05 into nanometer means 10 to the power minus 9 meter here. Okay, after that, next data, this one, angular velocity is given, omega. What is given here? 10 to the power 16 revolution per second means RPS. But this is not the SI unit, so we have to convert into the SI. That means we have to multiply with the 2 pi. Then only the SI unit will come radian per second. RPS means multiply with the 2 pi. RPM means multiply with 2 pi by 60. Okay. And after that, what they are asking here? They are asking here the, okay, magnetic moment. What is the charge of the electron? We know very well. 1.6 into 10 to the power minus 19 coulomb. Is it? After that, see, we know that. What is the formula? Magnetic moment formula. I have told you, remember that here. QVR by 2, or I can write here EVR by 2. Is it? But here V is not given, omega is given. So we will put V equal to R omega. So the moment you will put EV equal to R omega, it will become here ER square omega by 2. What I have done? I have put a V equal to R omega. This one I have done here. Okay. Then after that, what I will do here? I will just put here the values. E value how much? 1.6 into 10 to the power minus 19 into R value. What is given here? C. So even I can write here 5 into 10 to the power minus 11 square here into what is the omega value? Say here 10 to the power 16 into 2 pi. Okay. Somewhat calculation based question by 2. Okay. So just we have to do the calculation and all, and when you will do the calculation, you will get the answer 3.21 into 10 to the power minus 24 ampere meter square. You can write joule per Tesla also, not a problem. Correct option will be option C will be the answer. I am just teaching you the basics. Okay, great. Now students, after that we are going to see the next question, very important question. The question is, see, magnetic induction produced at the center of a circular loop carrying current is B. The magnetic moment of the loop of radius R is how much here? Okay, so what is happening that here? Let's take it is carrying some current here. No? So carrying some current is there. Okay, so due to this current, what will happen that here? There will be the magnetic field at the center inside. Okay, see, magnetic field at the center inside. Curl your fingers along the current, thumb is inside, magnetic field inside. Okay, but anyhow, we are interested in a only magnetic moment. So see, first let's see magnetic field. What is the formula? You should know the formula. B equal to mu naught I by 2R for the one turn. Only one turn is there. Okay. So what is coming? B equal to mu naught I by 2R. Now at the center. But current is not given in a question. So what is the value of the current? If I write here, this will come here 2BR by mu naught here. This is the current. Is it? After that, next step, if I talk about here the magnetic moment. What is the formula? I into A. So what is current? Current you know very well, see, 2BR by mu naught. And what is the area? Area of this. No? Area of this. If I talk about this total area. What is the total area? I can write here the pi R square. Okay. Just simplify this. So what this will come here? This capital M will come here. 2 pi dr cube by mu naught. Okay. I used to remember that even always. Directly sometimes we can use in a question. Correct option is option B is the answer, where B is the magnetic induction at the center. Okay, good. Next one, let's talk about here somewhat conceptual question. A square loop is carrying a steady current I. Okay, and the magnitude of its magnetic dipole moment is M. Okay, if this square loop is changed to a circular loop and it carries the same current, okay, the magnitude of the magnetic dipole moment of circular loop is how much here? Okay, so first I have taken here one square, and how much current it is carrying? It is carrying the current I. Okay, so in this situation, what will happen that here? In this situation, this one here, the magnetic moment of this square will be how much here? Number of turns 1 only. So I into area. Na? And let's take the side of this square is A. So what is the area? This will be IA square. We have got it. Okay. After that, what will happen that here? When this same square is converted into the circle and it is carrying what? it is carrying the same current I, is it? So in this situation, what will happen that here, let's take this circle is having radius r. Okay, so in this situation, as you know, current is same, so we can write here MC is equal to I into what is the area of the circle? Pi r square. But how to get the radius? Radius is not given in a question. The concept is the length of the wire in a square loop and the length of the wire in a circle, both will be what? Same. So here length of the wire, how much here? If I use the basic, this is A, this is A, this is A, this is A. Total perimeter 4A. This perimeter will be equal to the circumference of the circle. That means what is there? 2 pi r. Okay. So from here, if I write here I into pi, and what is the radius? Radius I can write here 4a by 2 pi, or I can write here 2a by pi. What is there? 2a by pi square here. This r what I am writing? 2a by pi square from here only. Is it? From here. Now after that, now what we are going to do? We are just going to divide it here. What they are asking? They are asking the circular loop. Okay. So I will write here, see, MC by MS. Circle to the square. Okay. So what this is coming here? See, this will come here IA square into here circle means, okay, IA square, here circle means what will come here? See, I into pi into 4a square, correct? I into pi into 4a square, okay, and above what will come here? The pi square will go, na? Because this pi square will go up, is it? So what other things will cancel out now? Kindly see here, this I and this I cancel, and from this a square is cancelled, and from this pi, 1 pi is cancelled, is it? So just let me see here, no? Correct only, na? R will come what here? 2a by pi only, correct now? So in this situation, what this will become here? Kindly see here, this will become here pi, and what will become here? Here in this situation, what will come? 4 will come, is it? Because they are asking here what? Circular loop only, no? Because MC by MS. Any mistake is there? Yes, mistake has happened. Why? Because just think please, where I have done the mistake. The mistake is done. First I have written for the square. Okay. So see here some mistake has happened. I will just do the some changes here. We have done MS by MC actually. Okay. So only I have written first square and then circle. Okay. So MS by MC is pi by 4. So if I write here M circle, what this will become here? This will become here 4 by pi into MS. And MS what is given here? This is given here M. Is it? So what is the answer? Answer will come here 4m by pi here. The concept is what? The length will be same and the radius can be written as 2a by pi. Otherwise the question is very, very easy. Correct option is here. Option D is the answer. Now kindly see here. Kindly see here. Is it? Great. Now let's see. Move to the next one. This question. The question is what? See. The magnetic moment associated with two closely wound circular coils A and B of radius 10 cm and B 20 cm respectively are equal, where NAIA and NBIB are the number of turns and current of A and B. Is it? So according to the question, what they are telling that here the magnetic moment are what? They are equal. They are equal for both the coils. Is it? So according to the question, I can write here MA is equal to MB. Okay. Now what is the MA? I have taught you M equal to NIA. Is it? So see, NIA. Okay. And which coil I am talking about here? The coil A. This one here. Is it? Here what you write here? NIA. And which coil I am talking about here? The coil B here. Is it? Coil B here I am talking about. After that, what this will become here? Kindly see very well. I can write here, see, NAIA by NBIB. It's better to take the ratio to get the answer in an easy way. So what this will become here? It will become here AB by AA. Is it? What is the area? No? Circular coil is there. So AB will be what here? Pi RB square. And here what this will come here? Pi RA square. Correct? So pi anyhow cancelled only. No? Pi anyhow cancelled. So this will become here RB by RA whole square. Now, so what is RB? You can see 20 centimeter. What is RA? 10 centimeter. So 20 centimeter by 10 centimeter. That means we can write here 2 square. Centimeter cancel. 0 also cancel. That means what can I write here? See, NAIA is equal to that side 4 is there. So 4 NBIB. Is it? See. Which option is correct here? You itself can see very well. NAIA equal to 4 NBIB. Correct option is here. Option C is the answer. Is it? See. JEE 2023 question. Next one, let's see. The question is see. a uniform conducting wire of length 24A is and resistance R is wound up as a current carrying coil in the shape of an equilateral triangle of side A and then in the form of a square of side A. Okay, even triangle also, what is there? Side is A. Even in square also, what is there? The side is A, according to the question. Now see, the coil is connected to a voltage source V. The ratio of a magnetic moment of the coil in case of equilateral triangle to that for square is 1:√y. What is the value of y? Okay, so let's see the question. The total length of the wire is how much here? 24A. Okay, so if I talk about for the triangle, the number of turns in the triangle, how many turns will be there? What is the total length of the wire? 24A. Okay, and each turn is having how much length? A. That means how much here? 3A, is it? So how many turns will come for the triangle? Total number of 8 turns will be there. One turn, how much length? 3A, and total length of the wire? 24A. After that, if we talk about here, the number of turns in the square. So total length of the wire? 24A, and length of one turn A. Total how much here? 4A. Okay, so from here what this will come here? It will become here 6. That means triangle will carry 8 turns, square will carry 6 turns. This is okay. After that, if we talk about here, what is the current? Current, anything they told? Okay, anyhow the current is same only. So here if I write here the next one, I am going to just write here the ratio. Magnetic moment of triangle to the magnetic moment of square. In the question itself they told you, first triangle to that for square. Okay, so triangle by square. Anyhow, let's take the current. Current let's take anyhow I. Current is I. How the current will be I? Why I am telling here I? Because see, here in this situation, what will happen that here? This I will be V0 by R. Because this coil is connected to the battery. Resistance of the total wire is not going to change. Here also what will happen that here? This I will be V0 by R only. Getting? Because this square turn and this triangle turn is going to connect with the battery. So resistance of the total wire is not going to change. Current will be what? Same only. Okay. So here I can write here, see, this is NT. Current is same I. Even you can write V0 by R also. And what we can tell? Area of the triangle. Then N square I into area of square. Okay. Now let's put the value. NT how much here? 8. Okay. And NS how much here? 6. Now into. After that, I anyhow cancelled only. Okay, and area of the triangle, you know very well, this is the equilateral triangle, half base into height. So base is A, height from the Pythagoras theorem, √3a by 2. When you will use this will come here, √3a square by 4. Area how much here for the triangle? √3a square by 4. And area of the square, what is there? A square here. Okay, after that we will just simplify this. You can see very well, this A square and this A square is cancelled. Okay, so just let me write here. From here we can write it 4 2 ja 8. Okay, and this 2 3 ja 6. Maybe it is looking somewhat complex, but anyhow when you will simplify this will come √3 by 3. Okay, and this will come here 1 by √3. And this one is this is what here? The triangle to the square magnetic dipole moment. But in the question what they are telling? 1:√y. So compare 1:√y and 1:√3. What is the value of the y? The value of the y is going to be, the value of the y is going to be 3. The value of y is going to be how much are students? This is going to be the 3. NET question is there. Very simple, very simple. Okay, great. Now let's see the next question is there. Now very basic question. See, two concentric circular coils of radii R1 30 cm and R2 50 cm are placed in XY plane as shown in the figure. A current 7 ampere is flowing through them in the direction as shown in figure. The net magnetic moment of this system of two circular loops is approximately how much here? Okay, so anyhow the magnetic moment formula is NIA. N is fixed, I is fixed. Which one is having more area? That will have the more magnetic moment. So you can see very well here. Let's take this is the coil 2 because radius R2. This is the coil 1. Which one is having the more area? The 2 is having the more area. So anyhow its magnetic moment will be more. And in which direction? You can see very well. inside the board along negative z axis. That means the answer is going to come along the negative z axis only. Answer will be either minus 3.5 or minus 7 k cap. That is the basic. Okay. After that, if I talk about here one by one, okay, so see, if I talk about here the first one here, M1. So what is the current is given? I, okay, I is there into radius over how much here? R1. So pi R1 square. Direction, curl your finger along the current, thumb is coming outside, that means along the positive z axis, it will come here k cap. Okay. Similarly, if I write for the second one, what is given here? Anyhow, the current is I, radius how much here? R2. So pi R2 square into direction, as I told you, put your fingers along the current, see, along the current, thumb is going inside. So this will be how much here? Minus k cap. Which one is more, M2 or M1? M2 is more. So resultant magnetic moment is going to be along the direction of minus k cap. Okay. After that, if I will simplify this here, the resultant magnetic moment, net magnetic moment will be what here? M1 plus M2. What will come? M1 plus M2. Just put the value M1 plus M2. What this will come here? M1 value is coming here. Kindly see here. I into pi R1 square k cap. And here what this will come here? See, the minus sign is there now. So see, I minus I into pi R2 square into k cap here. Is it? After that, just I'm going to take here the things common. So let's take I is common, pi is common, and I have taken minus k cap common. Now why I'm taking minus k cap common? Because anyhow we know it is going to be along minus k cap. Even you can take k cap common also, not a problem. So this will become here what? This will become here, see, R2 square minus R1 square. Okay. After that, we are just going to simplify this. So this will come here, vector M equal to what? I value what is given here? Kindly see here, the current is given here 7 ampere, so 7. Okay. Pi value how much is given here? See, 22 by 7 into minus k cap. This thing is done here. After that, what is the R2 square? 50 centimeter. That means 50 by 100. 50 by 100. So 0, 0 cancel. 5 by 10 square. That means 25 by 100 minus R1 square. R1 how much here? 30 centimeter. So we can write here what? 30 by 100 meter. 0, 0 cancel. So 3 by 10. 3 by 10 square means I can write here 9 by 100 here. Is it? Very basic. Convert centimeter into meter here. So this 7 cancel. It will come here 22 minus k cap. Okay. Take the LCM here kindly. 100. Okay. So this will come 25 minus 9. So see here 22 minus k cap, and this will come here what? 16 by 100. What is coming? This one will come here. Is it? So after that, when you will simplify this, this will come here just 16 into 22. Okay, this will come here 352 minus k cap and by 100 here. So 352 by 100 how much here? 3.52 minus k cap. So 3.52, anywhere options here 3.5 here 3.5 minus k cap is there. So correct option is what? Minus 3.5 k cap here. Is it? See, great. Now let's see, the last question is here, very basic question. See, a wire carrying current I is bent in the shape ABCDEFA. You can see here ABCDEFA. Okay, as shown, where ABCDA is where ABCDA and ADEFA. So see here again, see ADEFA are perpendicular to each other. How perpendicular to each other? Because this first one in a xy plane and this one in a yz plane. You can see also. Now see, if the sides of the rectangles are of length A and B, then the magnitude and the direction of magnetic moment of the loop is how much here? Okay, so side what they are telling that here? They are telling A and B. Let's take, okay, I have taken here, this is A and this I have taken here B. Okay, and both are in a which plane? They are in a perpendicular plane here. Now just like one notebook is there, na? Just one notebook you have opened like this kind of situation. Okay, so let's take, for example, if I talk about here the first one as ABCDA. So how can I tell here? This is going to be the one closed coil. I am going to take here, let's take here one imaginary wire is there. Okay, and here what is happening that here current is flowing in this direction also. Okay, current is flowing what here? The current is flowing in this direction. Is it? current is flowing in this direction, so this loop will complete. After that, the same current I will make it flow in opposite direction. Then what will happen that here, this loop will also close here. So here one imaginary wire I have taken, current is flowing in opposite direction, they will cancel it anyhow. So if you will take the pink color, this XY plane coil will complete. If you will take the yellow color, this XZ plane coil will complete, XZ plane coil will complete, is it? So now if we talk about here ABCDA, in which plane? In which plane? XY plane is there. Okay. So what is the magnetic moment? We can write here in this situation. First one I am writing here. The current I is flowing here. Area AB. Area is AB. Direction. Put your fingers along the current. That means now my curl fingers in a XY, X to Y. Thumb is going along which direction? Z direction. Is it? So this will become here the K cap. Okay. Similarly, after that, if I talk about here the next one, which one I am talking about here? This one, ADEFA. ADEFA. So in this situation, what is the M2? M2 is going to be this one here. This one here. In a which plane? This XZ plane is there. Like notebook is open. Is it? Like this, like this. This one I am talking about here. So in this section, what will happen that here? Again, the current is I. Area of the coil is AB only, na? Because this is A, so and this is B, so this is B, na? See here, this is B and this side is A, IAB. Direction, see, curl your fingers along the direction of the current in a ZX, then this is going along which direction? Y direction is there, so I can write here the J cap here. They see here, X axis, Y axis, Z axis, X to Y, this is the basic rule. If you curl your finger X to Y, it should go along Z direction. That is the basic to draw any coordinate system. That means this rectangular coordinate system. Okay. So this M1, M2 we have got here. After that, if I talk about here the resultant magnetic moment, how much here? Add both of them, M1 plus M2. So if you will add here M1 plus M2, what this will come here? IAB is common. Is it? IAB is common. So this will come here what? J cap plus K cap here. This is my resultant magnetic moment, but in a vector form. But here what they are asking here, they are giving here the magnitude is there. Okay. So if in case, if I talk about here the magnitude only, the magnitude is given by what here? Mod M. That means we can write here IAB and square root of coefficient of J cap square plus coefficient of K cap square. So this will come here what? Root 2 IAB. What is the magnitude? Root 2 IAB. Here also root 2 IAB is there. Here also root 2 IAB is there. Now the direction is important. So for the direction, what we have to do here? See, I will write here the direction. Direction means I can write here M cap means vector M by mod M. What I can tell? Magnitude vector M, that means vector M by mod M. What is the vector M? You know very well here. See, IAB J cap plus K cap by magnitude M. How much here? You can see very well, root 2 IAB. Is it? So what will cancel out here? Kindly see here. This root 2 IAB and this root 2 IAB is cancelled here. See, you can see this IAB and this IAB. IAB cancel. So what is left? J cap plus K cap by root 2 direction. Where is the J cap plus K cap by root 2? So see here, J cap by root 2, K cap by root 2. This side they are telling root 5. Root 5 is not coming. What is coming? Root 2. So correct option is here option B. The magnitude root 2 IAB. See here. Direction is this one, J cap by root 2 plus K cap by root 2. And vector form means anyhow this is the answer. This is the answer in a vector form. Can you see here? Okay. So students, I hope so. This video based upon the magnetic moment and questions based upon all this is very, very clear to you. Keep studying, keep growing.